everybody. Welcome to the next Palbox Secure presentation, which is going to be on securing your IoT against modern threats. I'm Chloe Bowen, product specialist here at Palbox, and I'm here with Bruce Snell. I'd like to thank our sponsors, HITRUST, Goodwin Law, Beyond LLC, and HIPAA Ready. Don't forget to take advantage of networking with the Whova app, and feel free to submit questions for Q&A anytime during the presentation, and we'll get to them at the end. You see the option to ask a question or engage in the chat when you're not on the full screen mode, just so you know. So any questions that we don't answer, we will follow up with a written response that we will email out to attendees. So don't worry about it, we'll cover your question. So a little about Bruce. Bruce Snell has more than 2 decades of experience in the information security field. He is currently the Global Vice President of Security Strategy and Transformation for NTT Security, a global technology services company. Bruce's background includes system administration and network security, including firewalls, intrusion detection and prevention, DLP, and encryption. Bruce has also been heavily involved in research on new areas of cybersecurity, most recently in IoT and OT security, which is what this presentation is going to cover. So without further ado, I'd like to welcome Bruce. Thank you for joining us.
Great, thank you very much. Let me share my screen real quick. Let's see. All right, can you see everything okay?
Yes, looks good.
Perfect. All right. So again, thank you for the introduction, Chloe. I appreciate that. So I'm going to talk a little bit here about IoT and OT. In particular, actually, what I'd like to do before we get started is really kind of do a level set on what we mean by IoT. For this purpose of this discussion, defining IoT as software or hardware that has a direct connection to the physical world, right? It's important to really understand what we're talking about when we talk about IoT, because it does tend to get a little bit broad in its definition, and so I think to just really kind of think about what we're talking about here today is probably good. So we'll start again. IoT, stands for Internet of Things. That's typically is thought of as traditionally as stuff in the home, but IoT also includes things like cars, connected cars, and connected industrial equipment, things like that. And in fact, the other aspect of it is operational technology, which is OT. You hear that referred to as IIoT sometimes, but this is really thinking about IoT specifically for industrial controls, critical infrastructure, things like power plants, factories, oil refineries, those sort of things. Those tend to go toward dealing with operational technology or OT. So let's take a look about, kind of some of the things that I've been thinking about from an IoT security perspective. And one is really is cars. Part of that is, you think about a car. A car is, something that a lot of us use to move around and, in our daily life. Although not so much these days. I think my gas mileage is, miles per month now instead of, or months per gallon instead of miles per gallon. But if we think about a car, right? We think more about what we're doing with connected cars and self-driving vehicles. When you start looking into a car isn't just one piece of equipment, right? A car has got a lot of suppliers providing information or providing parts. There are a lot of manufacturers, and the number of cars is obviously increasing to the point where predictions are looking at 125 million connected cars on the road by 2025. But when you start looking at a car, we can actually think of a car as a large compute device, right? Because your modern car has about 100 million lines of code, which actually starts introducing vulnerabilities, right? So that's where, if you think about a car actually has, on average about 50 different attack points, right? And it's not just the code. As you start looking at the car itself, this starts breaking down into all of the individual areas of the car that you have to think about. There's the central processing unit. There's the ODB, which is that, thing underneath the dash that you plug into to get information about your car. There's, when you're looking at self-driving cars, there's all the sensors that have to go into it to make sure that they can actually drive and detect people and other obstacles. One big area is infotainment systems, right? You've got Apple Car, or CarPlay and Android Car. You've got all of these other areas where people are basically providing these full infotainment devices that have full internet connectivity and all of this connectivity from the internet and pulling it directly into the vehicle, which again introduces another area of vulnerability. But it's not just the car itself, right? And this is why I'm using a car as an example, because you've got the car and you've got all of the issues that are associated with that by as a separate unit. But then to get everything to work well together, you've got all of these different backend layers, network layers, all of these other components that are built in, so that one car becomes part of a bigger ecosystem, and each layer of that ecosystem has vulnerabilities that have to be protected. And from a car perspective, going from a car, you also think about, wearables, right? Wearables is another kind of area where, at first glance, you're thinking about all these things that, the wearables are doing for you. It's collecting your information around, what your exercise habits are, your heart rate, things like that. And I am a junkie for all of this data. I try to track all of my, workouts and everything that I'm doing. But then it's not just a matter of that information that's vulnerable, right? As we start looking in deeper behind these, the kind of the first pane of glass, right? As we start looking deeper into what's being connected and what's being collected by these devices, you actually start seeing a lot of other data that can be used and referenced for all sorts of risk, right? If we start looking at, just take a smartwatch, for example. It's going to collect location data. It's going to collect, where you're going. It's going to collect your heart rate. All of these sort of pieces of information can be used to build a bigger picture for identity theft or for cyber stalking or exploitation. All of these issues start creeping up and become a bigger concern, right? So it builds a bigger issue, a bigger attack profile, if you will, from an attacker's perspective. And you think about it, as we start looking into some of the other initiatives that are going on around passwords, for example, you're seeing Microsoft and others doing experiments or projects on removing the password and identifying you by your movement, right? Identifying you by how you're typing on the keyboard, or identifying you by how you're walking, like your gait, right? And these are all sorts of things that can be easily collected by smartwatches and fitness trackers and things like that. So there's a lot of data out there that can be harvested by an attacker to exploit the individual. Especially when you start looking into some of the other things that are being done around targeted advertising, right? As if you look at advertising of, let's say that you've got the Bluetooth access points that are saying, okay, I'm seeing Bruce come into this Starbucks every day at 9:30, right? I'm serving up ads that are relevant for him. But that's also data that allows somebody to start tracking and start profiling an individual. So these are all sorts of things that kind of that are being built up that we don't really pay attention to. And now it's just on, it's not just on the device, because, when you look at IoT overall, again, it's part of a bigger ecosystem, right? So as we start thinking about, that one wearable, right? That wearable that, your fitness tracker, it's got a connection from that tracker to your phone. That connection goes from your phone into like a cloud services, right? So it can keep your login information, it can keep your history of your workouts, everything like that, in case your phone crashes and you need to have everything restored. And then all of that feeds back in. So it becomes this loop of information from your wearable up into the cloud, right? So there's all of these points that really make it easy for a hacker to start trying to find ways to break into that overall cycle. And again, this is one of those where, because the device themselves are so small and so functionally simple, they have to have this back end set up. And as you're creating this more complex and robust back end, you're also creating more holes and more issues that can come about. And one of the problems that we run into when you're developing things for IoT, and this is, definitely on the wearable side, and even on, you start looking into healthcare. I have a customer that I was speaking with that does, it's a Department of Special Surgery, and they build their own, implantable wearable devices that have Bluetooth connectivity and an app that they developed themselves. So of course, these people are building, an app to say monitoring your liver functions, or your, an implantable thing to monitor your heart rate. Their primary concern is building that functionality, and unfortunately, security kind of gets left off the table a lot. And part of that is because as they're building these things out, you're dealing with people that are experts in a particular field, but maybe not experts in writing an IP stack, right? I think about stuff that I was just talking to Chloe earlier about my Halloween projects, right? And I tend to involve like Arduino boards and Bluetooth connectivity and all this crazy stuff. I'm not an expert in that. I don't know how to build that connectivity, so I find examples of code and reuse those code examples to go in and build that functionality that I want. Well, the problem that we see in a lot of these devices is that they're reusing code libraries, then end up getting compromised, right? And so, there was over this year, there was a set of vulnerabilities collectively known as Ripple 20, right? And I think of the Ripple I always associate with late 80s, early 90s hip hop, but that's probably just me. But the Ripple was actually interesting in that it was attacking a commonly used IP stack that is used for embedded devices, right? So these are things like infusion pumps, or medical imaging, or printers, what have you. Basically anything that needs a compact operating system and needs an IP stack for that, they're using this off-the-shelf library. Well, the problem is that library has now become vulnerable, and now there's over tens of millions of devices that are impacted by this series of vulnerabilities. So what happens a lot, this happens a lot in IoT. This happens a lot in IoT in that people are rushing to get something out the door, and so they're grabbing code and grabbing parts that they can use quickly to be able to create that what we refer to as a minimally viable product. And unfortunately, a lot of times those vulnerabilities, there are vulnerabilities that exist that you don't know about for years. In fact, if you look at the trends of vulnerabilities in industrial control systems, it's an interesting trend line, because if you look right around the time when WannaCry or any of those things happen, you always see a spike after that of new vulnerabilities, right? And it's not that these vulnerabilities didn't exist before; it's they've always been there, but it takes one person discovering a vulnerability to make other people start looking, and then it becomes a bigger issue, right? And so now you start seeing these, more and more vulnerabilities increasing year over year, because people are now actively targeting them. So when you're dealing with developing for IoT, security has to become a really big issue, and there's kind of a path that you want to take for developing security, right? And one is really this concept of DevSecOps, right? And that's kind of one of those industry terms where it's really around developing secure operations around your programming. right? So this is all about developing steps and embedding security as you're doing the development of your code. This can save a ton of time and a ton of issues and concerns later on if you spend the time really heavily in the beginning to make sure that that code is reviewed and checked for vulnerabilities. Now, there's a lot of pre-baked solutions out there where you can just basically upload your GitHub or or whatever, your repository, into these solutions, and they will check for commonly known security vulnerabilities or commonly known issues. And that's just not looking for known problems, but it's looking for things like unchecked buffers to prevent buffer overflow, things like that. But really, building that security into the development process is what's going to help you long term, keeping secure when you're looking at IoT. And when you start thinking about IoT being used in places like the medical field and hospitals, one of the things that comes in really, really strongly is that network segmentation. Because there's a tendency to, once you've got something, let's say you've got a new imaging system that you're bringing online. Well, the most common thing is to just plug it into your general network so that it's easier to access, right? Because nobody wants to bug the network administrators to be able to say, okay, I need a route built, I need connectivity built from this machine to these devices or to these laptops so that I can connect to it. So they tend to just kind of throw everything on the same network, which is a problem in that if if one device gets infected, then it's going to start trying to spread elsewhere. I had a customer that had a huge infection of WannaCry in their network, and that all came from a smart microscope, right? And by smart microscope, it was basically a microscope that had an output and a laptop connected to it, and that laptop was infected with WannaCry. They brought it into the lab. The lab network actually was connected to the rest of the production environment. And so, once that infected system started spreading from the lab out, it basically ended up infecting their whole network, which is a bit interesting because the lab was, hermetically sealed, or not hermetically sealed, but basically one of those labs where, you need the clean suit to get in and out. You go through airlocks, et cetera. So it was preventing physical viruses, but wasn't obviously preventing, digital viruses from escaping. So that's where network segmentation can really come in handy. And what we're finding too is that monitoring is a huge benefit for securing IoT devices, because a lot of these devices you'll never be able to patch, right? There will be devices that have vulnerabilities. If we think about the Ripple 20 that I just talked about, there are millions of devices that are impacted by that there's not a patch for, right? And so in order to stay secure, you have to be continuously monitoring for new suspicious things that are happening so that you can go ahead and take action on that. And that's where kind of that advanced threat detection comes in play as well, because it's not just enough to monitor for your standard IT traffic, right? You have to be monitoring for new types of attacks that are trying to worm their way from one side to the other. We've seen instances of, industrial control systems being taken down by a virus that started in an infected PowerPoint that somebody got in HR, right? And it made its way slowly through the network over to the factory floor and shut down systems. So this is where you need that kind of that advanced detection so that you can see if there's something more interesting going on that you need to be paying attention to. And again, that's where tie that in with threat intelligence, right? It's not just enough to detect for known threats. It's really helpful to be able to see what else is going on around the world and try to detect for attacks that other people may be seeing at the same time. So that's just kind of a quick, a quick down and dirty on overall IoT security. So Chloe, I'll go ahead and open it back up for questions. And then you can see, there's my contact email and my Twitter handle if you want to, follow up afterwards if there's something else that you end up thinking about after the session's over.
Great, thank you so much. Thank you so much. We do have a couple questions from the audience, and also Feel free to write down Bruce's email and Twitter there if you want to follow up with him directly afterwards, obviously. So how about this? What are the unique challenges with IoT in the healthcare industry specifically?
Yeah, IoT in healthcare is really interesting because you're dealing with, especially now, when we're dealing with, with COVID, in the healthcare industry, we're seeing more issues of kind of the bring your own devices, right? We're seeing people that are bringing, their own tablets to connect to the network. Um, and those are typically people bringing things from home that may be infected and coming onto the network very quickly. Healthcare is also interesting in that, again, there are a lot of legacy devices that are remaining on the network, that are connected and aren't necessarily easy to patch, right? And I know there was some concern for a while. There was kind of this, um, I want to say rumor, but I guess, urban legend, if you will, that patching an imaging device would violate the FDA regulations around it, right? And that's actually not true. I've actually, was in a session where the one of the folks from the FDA was talking about how they've really relaxed their definitions of modifying health devices, to allow for people to actually update security and allow for people to provide patches and things like that. So there's a lot of work that has to be done in medical IoT, or in healthcare, because it's just so varied, right? If you look at industrial IoT, you're probably dealing with a particular type of device, but in healthcare, you've got tablets, you've got MRIs, you've got all sorts of things that are connecting on this one network, with a lot of people that are stressed, a lot of people that are overworked, and maybe are a little too quick to click OK if they're getting, an email or something that, a pop up. A lot of things kind of go out the window when you're dealing with high stress, high time crunch, and literally dealing with people's lives on the line. So healthcare can be extremely challenging.
Yeah, that kind of segues into another question from the audience, which is kind of about whose responsibility it is, to secure things. How much of it is up to the end user? And that could be either somebody as an employee, but also as an individual who's wearing a smartwatch or what have you.
Right.
Um, and how much of it is up to the manufacturer to secure?
Yeah, I think obviously the manufacturer has a lot of, responsibility to make sure that their code is secure, and that they're providing, that they're providing timely updates to their devices. There's nothing worse than having a device that has had a vulnerability for years and there's no fix for it, right? Um, so there is a lot of responsibility on the manufacturer. Um, and fortunately, I think, healthcare and, industrial controls and those areas they tend to be, I think in the past couple of years, they've been more quick to respond. Um, when I was working at McAfee a few years ago, when one of our researchers was dealing with, hacking an insulin pump, right? And that there was a whole, almost like a sub drama going on around, working with the manufacturer to try and get some sort of patch fixed. In fact, he actually was threatened with a lawsuit, just for bringing up the issue. So that's changed, thankfully, over the past few years. But a lot of the responsibility, when you start looking at things like tablets that you're bringing from home, basically any of the BYOD, the bring your own devices, the responsibility does really heavily lie, on the individual that's bringing that device. I always tell, my friends and family, to the point where they're sick of hearing it from me, is that always update your devices, right? Turn on automatic update for your phones, your smartwatches, everything that you can do, because there's so many vulnerabilities that are being discovered every day, that it's really in your best interest to make sure that you're updated, so that you're not taken advantage of by these issues.
Yeah, actually, that segues into, we probably have time for one more question.
Sure.
Where do you start with securing your IoT? And that could again be as an employee or as an individual. Like, is it just updating, making sure you're updated, or is there anything else you can do?
Yeah, I think that's a good start. Is making sure you've got a solid update and maintenance window. But again, that becomes a bigger issue when you have things like industrial control systems that may have an 18-month maintenance window, right? That you can't necessarily reboot because it's supplying power to the eastern power grid, right? But a lot of the responsibility, lies, and a lot of the steps that you can take are, there's a lot of classic security things that you can do. Things like network segmentation, right, to make sure that your IoT devices that are connecting to your network are segmented off. That there's not a lot of cross traffic going back and forth between personal use devices and devices that are being used specifically for work. Um, there's a lot of things that you can do with making sure that you're purchasing smartly, right? So as you start looking into IoT devices, and I think this applies more towards home than like than business, because a lot of if I'm looking at medical things like that, a lot of those you don't have a lot of choice. There's a limited number of manufacturers. But let's say we did an episode of a podcast where we talked about hacking a smart coffee maker, right? Like if you're going to buy a smart coffee maker, well, look and see, what are there vulnerabilities for that product already existing? And if there are, maybe look at something else, right? So I think on a consumer, you've got a little bit more power of choice. But unfortunately, on the enterprise side and the professional side, you're kind of locked in to what you have to buy. So then you have to build up that infrastructure around it to mitigate those threats. And I say mitigate because there's going to be a lot of things that you can't fix. For example, if you're on a factory floor and you have a safety information system that somebody is basically is what somebody's going to hit a big button to let people know something's on fire, right? You can't put a password on that system, right? You can't have a 14-character password that somebody has to enter in before they can say, okay, the building's on fire, right? So those are things that you're never going to be able to fix. So you have to look at pushing kind of the threat further out, through network segmentation, through good firewall rules, through network IPS rules, things like that, to take a step back and try to make the outer wall as defensible as possible. And so that, the things that you can't fix are protected. And the things that you can fix, obviously go ahead and try to get an aggressive patching and updating window.
Yeah, that all makes sense. Thank you so much for this presentation. It's been really helpful, giving us some action items that we can all do to secure our personal and professional IoT devices. So I think there's maybe another question or two that we didn't get to, but we are going to be writing responses to all of those for the attendees. So we'll get answers. The next session starts in 10 minutes. That's at 12:10 Pacific time, where I am. It's going to be about regulation and innovation in healthcare. And don't forget about the networking and chat abilities in the Whova app. So thank you again so much, Bruce.
Great. Thank you very much. Take care.
Bye.